In example 2 here, all we're doing is writing down our transformations to take y equals cos x into these equations here. So first things first, on this very first one here, for example A, I notice that I don't have a dedicated b value, so I'm going to quickly factor to make a dedicated b value. So we got y equals 2 cos, let's factor out a 2 there, factored out the 2, so we have x minus pi over 2 plus 1. And again, we just graphed this equation previously, so it should seem familiar. So to write down our transformations, let's see what happens. So we have a vertical stretch, that's by a factor of 2. We have our horizontal stretch, that's by a factor of 1/2 because you had to reciprocate it to pull it out. And again, that's different from your b value. This statement is different from your b value. You have a horizontal translation, that's going to be horizontal translation, that's going to be pi over 2 to the right, and you have a vertical translation 1 unit up. And again, this all four of these characteristics could have been translated in terms of trigonometry. So you have a amplitude, you have a this 1/2 which is descriptor, and you have a which would help you find your period. You have a phase shift, and this is your vertical displacement. Okay. In example B, that's okay. In example B, we also want to start off by factoring this equation. So if I rewrite this equation, it's going to look like y equals 3 cos 2 bracket x. And here you got to be very, very careful on this factoring. This is going to be minus pi over 3 plus 2. And again, same characteristics. So you have a vertical stretch, horizontal stretch, a horizontal translation, and a vertical translation. And of course, all of these were equivalent to amplitude. This one here is going to help you find your period. You have a phase shift, and you have a vertical displacement. So what do we have? Vertical stretch by 3, horizontal stretch by 1/2, horizontal translation pi over 3. Sorry, that's a pi. Ooh, let's try that again. Pi over 3 to the right. And of course, you have a vertical translation 2 units up. Last but not least, here we go. We have 2 sine 3, 2 sine x plus 3. Again, this is not in cosine, so first things first, we got to switch this over into cosine. So, a little tricky on this one, but here's the change up. Y equals 2 cos, and if you're starting at cos, that means you have a phase shift ultimately. And so that's going to be x minus 90, or you can use degrees, or you could do it in radian. We've done 2 radians, so I'm just going to switch it over to degrees here. X over x minus 90, which is pi over 2 by the way, plus 3. And here, let's write down our characteristics. So you have a vertical stretch by a factor of 2. No horizontal stretch there. We do have a horizontal translation. That's going to be 90 degrees to the right, or pi over 2 to the right. And you have a vertical translation at the end there, which is 3 up. And again, that vertical translation is really your vertical displacement. In the next example here, in example 3, it says determine the equation of the graph given. And so you want to write a graph with sine and write one using cosine. Here's your graph. So what's the first thing that we want to look for? We want to look for a vertical displacement. The way that we can do that is one of two ways. You can use an equation or you can sketch it on your graph here. So I'm going to do it both ways actually. I'm going to use our equation and then sketch it on our graph. So first thing I need to do is find my max and min. It looks like our maximum value is around here, so I'm going to put a coordinate dot there. Minimum value is right around here, put a coordinate dot there. So quickly off to the side, you have a max equals 4, you have a min equals 0. Let's find vertical displacement. So D for vertical displacement is equal to max plus min. So I'm just going to jot down our equation first. Max plus min divided by 2. And in this case here, this is going to be 4 plus 0 all divided by 2, which is just 2. So that also means at y equals 2, I have a vertical displacement line, and I could have done that, also drawn it in right away if I knew that, hey, at 2 it splits my graph, my top and bottom, right in half there at 2. Up next, I'm going to look for my amplitude because I have, again, my max and min. So amplitude is equal to the absolute value of your max minus your min. Divided by 2. And so what do we have? We have the absolute value of your max, which is 4 minus 0 over 2, which is still 2. So that means you have to be about 2 away, and that looks like a distance of 2 away from your vertical displacement line from your max and min. So max is about 2 away, min is also about 2 away, so yes, we have an amplitude of 2. Let's talk period. Well, when do you see one full cycle? Well, I can see a full cycle if I started from here for sine from 2 pi going all the way up, going all the way down. Oh, I don't see any more of this graph here, so that doesn't work for sine if we start at 2 pi. We start for cosine. Cosine would start off at 3 pi because it's going from top to top. Again, top going all the way down. Ooh, we don't have enough of a graph there, so what can we do? Let's take a look at our y-axis here. So our y-axis, our period is going to be from 0 goes downward motion, go all the way up. If it started to repeat, it would have done another loop down, but it doesn't. It goes all the way up, goes all the way down. So I know that one full cycle, one full rotation is between 0 and ending off at 4 pi. You could have also pulled that right out of your equation if you had an equation, but let's jot down that we have one full cycle, so cycle or period is equal to 4 pi, but we need to find our b value. Therefore our b value is equal to, you have to go 2 pi divided by 4 pi. So here pi and pi will cancel. 2 over 4 is the same thing as 1/2. So that's our b value. B equals 1/2, and so 1/2 would go into your equation. You don't have to reciprocate it by any means. So our phase shift we're going to leave alone because it's going to be dependent on which graph we have. So phase shift for sine has to start off at 2 pi because sine starts off midway between your peak and your valley. So sine would start off at 2 pi, cosine would start off at 3 pi because it goes from top to top or from hill to hill. But then we also have two other extra graphs that we can talk about in here as well. So let's jot down a few of our answers. So the more common ones first. Let's go with sine. So I have y equals an a value of 2, sine b value of 1/2, and that's going to be x minus, and here we're going to talk phase shift. Phase shift again for sine would have been at 2 pi, so I'm going to go minus 2 pi because we would have started to the right by 2 pi there. Close, double close, and we had a vertical displacement at 2. So there you go. That's going to be my first equation. My second equation, and I'm just going to write it right beside, is going to be the cosine curve. So my cosine graph is going to be y equals 2 cos, again bracket 1/2, and really everything's staying the same except for our phase shift. Minus what? Well, where's that first top? Well, that first top was at 3 pi, so it's going to be minus 3 pi instead of 2 pi, bracket, close, close, and we have that plus 2 there at the end. There we go. That's going to be my cosine curve. And then, even though these are the two most common answers, we also have other answers. And hopefully, you're going to see one of each. So for this one here, sine, I can say that sine, instead of starting off at 2 pi, I can say it starts off at 0. But if I went down, halfway down, all the way up, repeating, going to the hill and then down, then it'd start repeating. I can say that's a negative reflection actually. So I can say something like this: y equals negative 2 sine. And if I'm starting at 0, look for the change up here in our equation. This is going to be 1 half. It's just going to be x, no phase shift because we're starting at 0, plus 2. And there you go. That's going to be our negative reflection of our sine curve, which works right there. And if we wanted for our cosine, it'd look something like this: y equals negative 2 cos. Well, if I'm a negative cos, if negative meaning I'm going from value to value, the first value I see is at pi. So we have 1 half x minus pi this time instead of 3 pi for a starting point, plus 2, and there you go. So you have really 4 equations that you can jot down here. Any of these 4 would really work. So yeah, just be aware that you have 4 equations, 2 regular ones that most students kind of get, and these bottom 2 here with the reflections are a bit trickier. For our last example today, we have example 4 here, and again, we just want to derive the equation, so let's pull off some information. So first things first, I'm going to find my max and min. First min value I see, negative 4, the first max value I see, positive 6, so I'm going to jot those down. So I have a max equals 6, a min equals negative 4. Finding displacement is going to be max plus min divided by 2. So let's do that. So we have 6 plus negative 4 divided by 2. So that's 2 over 2, which is ultimately just 1. So right at y equals 1, I'm going to draw in my vertical displacement right away. And there you go. From here, you definitely find your amplitude from the graph or from equation. So amplitude is equal to absolute value of max minus min divided by 2. Oops, that division symbol went a bit longer. There we go. So here we have absolute value of 6 minus negative 4 all divided by 2. That's 10 over 2, which is just 5. So that means from our vertical displacement, are you 5 away? Well, we're at 1 here going all the way down to negative 4, that's 5. 1 here going all the way up to 6, that's also 5. So yes, our amplitude definitely works. Period. Well, when is one full cycle? Just try your best to spot a full cycle, so either you can go from bottom to bottom, top to top, or a sine curve which is starting midway, so it starts here, going all the way up, down, down, and all the way up. But all you need to do is fill in, well, what is all of these other coordinates? So it's missing. So we got pi, 2 pi on here, but what's all of this in between? So I got 1, 2, 3, 4, 5, 6, 7, 8 pieces here. So in terms of this, we're basically going up by 15 degrees. So I'm going to go 1, 2, 3, 4, halfway. This one here, that's pi over 2. Half of pi over 2 is, of course, pi over 4. So I have a quarter. This is 1 quarter, 2 quarters, which is pi over 2, 3 quarters right here. So this is 3 pi over 4. 4 quarters, or 4 over 4 is just pi. Here would be 5 quarters, so 5 pi over 4. 6 pi over 4 can be reduced down to 3 over 2, 7 pi over 4, and of course 8 pi over 4 is the same thing as saying 2. So there you go, I have a few of these jotted in. So hopefully this is going to help you figure out your period. So what's your period? Again, you can go from top to top. So we're looking at from 3 pi over 4 until 7 pi over 4. And so if you take the difference there, so 7 minus 3, that's 4 pi over 4, which is just pi. So period is just equal to pi. Another way you could have found period, instead of going from top to top, you could have just calculated the sine curve. Well, from pi over 2, you go up, you go all the way down, then you end off here to 3 pi over 2. Well, if you went 3 pi over 2 minus pi over 2, that's just 2 over 2, which is just pi. So using a sine curve, you could have seen it. Or if you used a negative sine curve, you could have also seen it as well. So it's starting here at 0 with no phase shift, 0 going all the way down, going all the way up. Here it ends off at pi, so again, your period should just be pi. So therefore, our b value is equal to, in terms here, because we're in pi, it's going to be 2 pi divided by pi, which is just 2. So that means you should see 2 full cycles between 0 and 2 pi. Well, do we see 2 full cycles? Well, if I start at 0, that's a 1 right there, and that makes 2. So we definitely have 2 full rotations or 2 full cycles there. So let's jot down our equation, and we're going to have a few different options on this one here, so whatever really works. So let's do a sine curve first. So we got y equals a value of 5 sine b value of 2. And in this case here, if I wanted the first proper sine curve, it'd be at pi over 2. So this is going to be x minus pi over 2 for a phase shift. And we had plus 1 there. So that's going to be the real first one there at pi over 2. The next one is, let's do one without a phase shift. So we got y equals, well, without a phase shift, I'm right here. This is a negative sine curve, so I'm going to go negative 5 sine 2 of x plus 1. And so this one here, with that reflection there, no phase shift needed. Let's talk in terms of cosine. So we have y equals 5 cos of 2, and the first cosine curve I see is at pi over 3, or sorry, yeah, 3 pi over 4, sorry. So where you have x minus 3 pi over 4 there plus 1. So that's usually the first one that most people see. The second one is if you had a reflected cosine curve, so that's y equals negative 5 cos of 2. You have x minus, and you're shifting it to pi over 4 to the right. And so you'd be starting at pi over 4. And so these 4 here are your more typical 4 that most people see. You could have started off in the negatives here as well. That could have worked. You could have started off all the way over here as well, but usually I start around as close as I can to that y-axis, and so these 4 are our usual typical equations. And that's the end of our lesson. So if you have any questions, please feel free to ask.